Assalamualaikum warahmatullahi wabarakatuh to Madam and fellow friends. First of all, thank you for giving us the opportunity to present our project today. So our project title is Sunscreen Web Archive Repository. Before we begin, let me introduce our group member. My name is NURAZRINA binti ROHIMI, and let me introduce my group member. This is EFAZATUL FAIZAH binti AZHAR and PUTERI NURAZRINA binti HASHIM. Without further ado, let's begin our presentation.
Assalamualaikum warahmatullahi wabarakatuh. So today we want to present our project, the Sunscreen Web Archive Repository. It's a web-based platform specifically designed to collect, preserve and provide long-term access to reliable information on sunscreen, UV protection and skin health, by utilizing HTTP thread and web recorder to archive selected website. We ensure that these valuable digital resources remain accessible for education, research and future reference, even if the original website are modified or removed.
For this project, we chose the Sunscreen Web Archive Repository because sunscreen provides important information about skin health, UV protection and skin cancer prevention. However, the information on this website can change or even be removed over time. Therefore, Web Archive is important because it preserves the original website content for future use. This repository also stores archive website metadata, WARC file, SMS net detail, and website analysis report in one organized platform. It makes it easier for students, research, healthcare professionals, and the public to access valuable sunscreen-related information. This table compares a database repository and a web portal repository. For our project, we select the web portal repository because it is easier to access using any web browser. Users do not need technical skill or database knowledge to use it. It is also more user-friendly, making it easier to search for archive website. Therefore, the web portal repository is the best choice for preserving and sharing sunscreen-related information. This slide shows the advantage of using a web portal repository for this project. First, easy accessibility. Users can access the repository through any web browser using requiring technical knowledge or database software. Second, digital preservation. The repository preserves important sunscreen-related websites and ensure the information remains available if the original website are updated or removed. Third, organized information. All archive website metadata, WARC file, and report are stored in one centralized platform, make information easier to manage and retrieve. Next, support education and research. Students, lecturers, research, healthcare professionals, and the public can use the repository as a reliable reference for learning and research. Finally, website analysis. The repository includes analysis using tools such as HTTP thread, weblaser, XML sitemap, and web recorder, allow users to better understand website structure and web archive technology. Overall, this advantage make the web portal repository an effective platform for digital preservation and information sharing. The purpose of the project is to develop a sunscreen web archive repository that can preserve, organize, and provide long-term access to sunscreen-related websites and digital resources. This repository ensures the valuable online information remains available even if the original website are updated or be removed. There are four main objectives of this project. First, to develop a web-based repository for sunscreen-related websites. Second, to archive selected websites using HTTP thread and web recorder in WARC format for long-term preservation. Third, to organize the archive content using descriptive, technical, and preservation metadata for easier information retrieval. Finally, to provide users with easy access to archive website, WARC files, metadata, and website analysis through a single platform.
Next, I will explain the content architecture of our Sunscreen Web Archive Repository. Content architecture is refer to how information is organized within the repository to ensure users can easily access and retrieve archive resources. So, first is structure content. Repository is divided into home, about, directory, HT thread archive, web archive, analysis, and about us. Each section has a specific function to organize archive resources and improve navigation. Next is content models. It contains archive websites, metadata, work files, HT thread files, screenshots, and analysis report. The related resources are stored together to support efficient management and long-term preservation. Lastly is information architecture. It uses a hierarchical navigation structure with descriptive metadata. It consistent layout and navigation help user retrieve archive information quickly and easily. Next, I will explain the web feature implemented in our repository. Our repository includes three main web design features, which is first is helpful navigation, which provide a consistent navigation menu for quick access to repository page. Next is responsive design, which adapt automatically to desktop, tablet, and mobile device. Lastly is user-friendly interface, which use a clean layout, readable typography, and organized content for a better usability. Besides these design features, our repository also provides a website directory, httrack archive, web archive and analysis findings page where users can access archive website and view technical analysis reports. Lastly, the layout and design for our repository. This website is developed using HTML5, CSS3, Bootstrap 5 and JavaScript to create an responsive and interactive interface. The layout consists of several main components, including the navigation area, which provide quick access to home, about, directory, httrack, web analysis and about us. Next is a header area, which display the repository title and navigation menu. There's also a main content area, which presents archive websites, metadata, web files, httrack, archive, and analysis results. Lastly, we have the footer area. It contains copyright information, project details, and development credits.
For our methodology, we design a systematic navigation flow to ensure an intuitive user experience. As shown in our horizontal navigation flow, user can easily move between sections such as home, about sunscreen, directory, and our technical analysis page without navigating complicated processes. Our structured navigation flow further organizes this content. The home page acts as the central hub connecting all repository sections. The About Sunscreen and Directory sections provide organized educational content and categorized website lists. The httrack, WARC, and Analysis section display our archiving result and technical findings from tools like Webalizer and Web Recorder. Overall, these consistent structures allow users to access authentic and organized information efficiently. Moving on to our page design, we have developed a user-friendly interface to ensure clarity for all visitors. To begin with, our homepage serves as the main entry point, providing a clear overview of the repository's purpose to enhance the overall user experience. Furthermore, the About Sunscreen page offers essential educational content, such as benefits and SPF information, to help increase public awareness. In addition to that, we have a directory page that systematically lists and categorizes websites into health, government, and commercial sectors, allowing users to find specific resources more efficiently. Meanwhile, our httrack and WARC page display the actual result of the archiving process, including file details and status, which are crucial for future revision. Moreover, the analysis page presents technical findings, such as website technology and structure, using tools like Webalizer. Finally, to conclude this section, our About Us page acts as the face of our project. It provides the project background, our mission to bridge the gap between complex science and public understanding, and the accreditation of our team members. This transparency is vital as they establish credibility and build trust with our users, ensuring they know exactly who is responsible for the information they are accessing.
I will explain the web archive preservation plan. The purpose of this preservation plan is to ensure that valuable online information related to Sunscreen remain accessible, authentic and usable for future education and research. To achieve this, our repository follows three main preservation activities, which is data capture, scooping and frequency. The first preservation activity is data capture. In this stage, we collect information from trusted websites related to sunscreen, UV protection, skin cancer and prevention, and skincare educations. The websites are archived using httrack to create offline copies and web recorder to generate web file for long-term preservation. After the website are captured, important metadata such as website title, URL, archive date, archive type, and file size are recorded. Finally, quality checks are performed to ensure that all web pages, image, document, and links have been archived successfully. The second preservation activity is scooping. Scooping determines which website and digital resources should be included in the repository. We only archive reliable and relevant websites published by government agency, healthcare organizations, the World Health Organization and educational institutions, and trusted skincare brands. The archive content includes web page, image, PDF documents, infographic, and other educational materials related to sunscreen. Meanwhile, irrelevant, duplicate or restricted content is excluded to maintain the quality and reliability of the repository. Lastly, the third preservation activity is frequency. Our repository archives websites every 3 months as sunscreen-related information does not change frequently. However, websites published by health authorities may be archived more often whenever important announcements or updated public health guidelines are released. After each scheduled capture, repository administrators review the archive websites to ensure all the web pages, image, document, and hyperlinks have been captured successfully. This process helps maintain accurate historical version of web content while ensuring the repository remains current and relevant. Lastly, the risk management and quality assurance. To ensure the reliability of repository, we archive only publicly accessible websites and follow websites policies such as the robots.txt protocol. To reduce the risk of incomplete archive, quality checks are carried out after every capture. If any web pages or files are missing, the website will be archived again. Regular backups and metadata verification are also performed to protect archive resources. Finally, the quality of the repository is evaluated based on 4 criteria, which is completeness, which all important content is archived; correspondence, which archive contents match the original websites; coherence, which navigation and contents remain consistent; and lastly, integrity, which archive files remain authentic and accessible. These measures ensure that the archive websites remain accurate, authentic, and accessible for future users.
Moving to the technical implementation, this section shows how we apply this metadata directly into our HTML structure. The metadata elements such as website name, categories, countries, and URLs are organized into table columns. This ensures that all collected information is displayed systematically, allowing users to identify, access, and manage archive website more efficiently. Regarding metadata, we have classified into 3 main categories. These include descriptive metadata for primary identification, technical metadata to record the technical characteristics of our archive, and preservation metadata to monitor the storage status of the files. We use descriptive metadata to act as the key identifier for our archive sources. As you can see, this includes essential details like website name, content title, and publication year, which allow users to easily find and understand the content within our repository. Next is technical metadata. This captures essential specifications such as file size, archive date, and WRC file details, which allow repository administrators to effectively manage and maintain the accessibility of our digital resources. Finally, we have preservation metadata. This is critical for the long-term maintenance of archive resources, as it allows us to monitor and verify the completeness and authenticity of every file within our system. In conclusion, this project has successfully preserved valuable health information by combining robust archiving tools with a structured metadata framework. We have created a reliable, user-friendly platform that prevents the loss of digital content while promoting community awareness regarding skin health and UV protection.